We've been discussing golden hydrogen in Europe and beyond. Today we want to spend the envelope even further and consider remote offshore opportunities. So what immediately comes to my mind is safety, is logistics and maintenance, and obviously also export of produced H2. Can you tell us what's on your mind?
Yeah, transport and initial investment. Well, let's start with the toughest one first. The worst case is actually Stockman. It's a huge field. It's the 5th biggest in the world, but it's a stranded gas development. And some of the challenges is actually, you know, it's 300 meters of water. It's 550 kilometers from shore. There are icebergs in the Arctic, big wave action. And on top of everything else, it's more than 5,000 kilometers to the nearest market. So the question we can ask is, of course, you know, would CO2 to H2 be more or less economic than this stranded gas development? And the answer is, yeah, it would be a lot more economic because essentially the facilities all sit onshore. We could easily fit an SMR plant next to the gas facilities, and then all you would need is an extra pipeline to also transport the CO2 offshore. But then the second question is, you know, would that be sufficient to make this whole development economic? And well, I won't even attempt to answer that question now. Another tough one to look at here, you know, would be Prelude. What you see here is, you know, a big ship and a very, very, very big ship. You know, the Prelude floating LNG is essentially, you know, an LNG plant, you know, fit on a big ship. And, you know, all I'm saying here is if you can put a whole LNG plant on a ship, you could also put an SMR plant and a duct plant on a ship. So, you know, theoretically, you know, a development is possible. You know, would, you know, that development with CO2 to H2 be more or less economic than a floating LNG development? Hard to say. You know, could it still be converted to CO2 to H2? Probably not.
Yeah, I'm coming back to my initial point. So you mentioned Stockman and Prelude. So none of them are easy. Yeah? I mean, Stockman is located in the Arctic. We know for Prelude in Australia, for instance, it has had its teething problems with liquefaction of natural gas. So again, the question: how can that be economic if you extend or expand those concepts to golden H2?
Yeah. So these are not the ones that I would do first. As I said, you know, they're in a sense the worst case. You know, but if the transition to green hydrogen and green energy, you know, goes slower than expected, you know, then these projects, you know, would be a fallback, could come to the rescue if we're willing to pay a higher price for carbon negative energy. So in principle, a very high hydrogen price versus natural gas could pay for any development, you know, if it's extremely high. And indeed, hopefully we won't need that, but they're there once, let's say, the hydrogen price goes to $10 per kilogram.
Yeah. Yeah, if we stay closer to home and look at, for instance, at the Netherlands, so we have the Porthos and Athos projects, which are currently essentially being developed, and that's shallow water offshore the Dutch coast, and it's conventional CCS. Do you probably see an opportunity for golden H2 there as well?
Yes, absolutely. These are all proven technology, and they can easily be converted to CO2 to H2. And the revenue for H2, you know, even at a much lower hydrogen price, you know, would easily pay for the extra investment. A further advantage, of course, is that you don't have to wait until these gas fields are empty. You still produce the remaining gas in any case. So just for example, you know, here they're taking the CO2 from onshore plants and then sending it offshore. Yeah, so we could easily put an SMR plant next to these onshore plants, and then also send the CO2 to offshore, and then send this the remaining methane back to the SMR plant, and then export the hydrogen. An even better option, preferred in my view, is if we could fit the SMR and the duct plant also offshore, then we would need only one pipeline going back, which is just the hydrogen, and sell it there to a big hydrogen hungry market. So essentially, it's really just about weight limitations. What can we actually fit offshore versus onshore? And my favorite example here is the Lula FPSO. Oh, by the way, these are fixed structures and floating structures, and most of the shallow water is done by fixed structures. But if you use the ship like the Lula, I find that absolutely amazing. It actually does a lot of production and storage and offloading of oil in that ship. But in addition, that one has water injection facilities on it, and CO2 separation and injection facilities, all on a single ship. And that's in 2,000 meters of water and 5,000 meters total depth, and it's 300 kilometers offshore. So a lot is possible.
Yeah, so to reach scale, you would naturally target sort of sizable offshore gas accumulations. And what springs to mind, obviously, is the Middle East. Would you have examples for the Middle East as well?
Yes, and these are obviously the low-hanging fruits here. Well, let's start with Ghasha. It's currently being considered for development. It's offshore Abu Dhabi. But it could be reached with artificial islands, which they're actually building. So, and you can imagine, if you're putting the gas facilities on a new island here, then you can also put SMR facilities and injectors and duct on that same island, and that would be much more economic than this domestic gas development. Because the domestic gas, in the Middle East, is a lot cheaper, for instance, than in Europe. So the incremental benefit from hydrogen, will be a lot higher. And even more interesting than Ghasha is Ghasha's big brother, which is the Qatar North Field, just across the border, really. So it's the biggest in the world. It's got 35 TCM. You see, it kind of partially straddles the peninsula, so you don't even need an extra island. And what you see on that peninsula is a huge chemical plant, including LNG, gas to liquids, hydrogen, H2S removal, liquids processing, and compressors. And you could easily, in addition, fit an extra SMR plant, a duct plant, CO2 injectors, CO2 compressors, and you would hardly even see a difference. And duct you might not even need, because you could take the CO2 from the big chemical plant here.
Yeah, since you mentioned artificial islands, this of course is a technology that has been proven in the development of the large Kashagan field, where they essentially build and use artificial islands. But that's just a side mark. Let's go back for the time being. Let's go back to Stockman. There are other prospects in the Arctic, albeit smaller. What they all have in common is a large environmental sensitivity, and it's the remoteness, obviously. So even if you would manage the technical and non-technical challenges, which is the sort of addressing the environmental sensitivity appropriately, how would you bring the H2 to markets?
Yeah, that's exactly the critical point here. So, if you look at the Arctic islands in Canada, for instance, lots of stranded gas there. In principle, they would be, very easy to develop. They're easily reached from natural or artificial islands here. But how do you want to get the gas out? Pipelines will be tough. So we have to look at transport by ship. which could be via LNG, liquefied hydrogen, ammonia conversion, and so on. But ships have their problems as well here in the Arctic. They will suffer from icebergs, and the routes are not shippable all year yet. This, for instance, sits on the Northwest Passage, which we expect to become ice-free due to global warming. But that's not something we want to wait for, and that presents a detour in itself. So a new idea could be lighter than air transport with zeppelins or balloon powered by the jet stream. And this opportunity then also only works for hydrogen, because the hydrogen is much lighter than natural gas. So everything else has the same problems, but the hydrogen actually has a viable solution to get the gas out.
Yeah, so hang on. So you're talking about balloons and jet stream. That sounds pretty far-fetched and has a pretty tainted history. So open question: are these technologies seriously being considered for long-distance shipping of goods?
Yeah, it's another proven technology that has fallen out of favor because of a disaster that happened almost 100 years ago. So, to be honest, I don't think it's seriously being considered right now. But the authors of this paper here, they cite 84 recent research papers, and they claim that with today's materials, zeppelins could be built 10 times as big in all dimensions, and then they could deliver 2 kilotons of hydrogen as payload per flight. So for perspective, Shell has just built or announced a new electrolyzer, the biggest in Europe, and that can produce 60 tons per day. So it's in the research phase, let's say TRL 3 or 4, but it could be rapidly matured if somebody was willing to invest. And by the way, it's much safer than most people think. Firstly, zeppelins could be flown unmanned these days, and assuming 20 flights per year would be 40 kilotons per annum. You would need 25 zeppelins for 1 megaton per annum SMR plant. And of course, it's not just for golden hydrogen, but think of green hydrogen produced in the Sahara Desert, for instance, and delivered to a market in Bavaria. So bottom line, with that, you could transport the hydrogen from the Arctic, even potentially, from Stockman, just across the pole, and that could then go to the U.S. West Coast or anywhere else in the world.
Yeah, so many of the developments you sketched will have lead times of decades. That's technical maturation, that's approval lead times, etc. That'll take decades. So on the other hand, we expect humans' energy provision and consumption to be carbon neutral by 2050. So in the sort of general perception, this is sort of green energy. The whole system runs on green energy in 2050. So why do you think somebody would even invest now in golden hydrogen in remote areas, in particular in remote areas, the ones you sketched? Isn't that coming too late? Is that possible?
Yeah. So first of all, these climate targets that you quote are very ambitious, and they will be hard to reach and very expensive without any CO2 removal. And even the IPCC has projected that some CO2 storage and removal will be needed to reach these targets by 2050. But even if we could reach them with just renewable energy alone and no CO2 storage, wouldn't it be nice if we could reach them 10 years earlier and much cheaper with green and golden energy? So who would invest? Yes, investors would be high risk, but high reward ESG investors. Golden hydrogen is potentially an $80 trillion global business, as we will see in a later talk. And the margins will not depend on how fast green hydrogen will mature, but how expensive green hydrogen will be, once the market is saturated.
Yeah. Now,